To recap our vocab, the ends of our box and whisker plots, aka the whiskers, they represent our low value and our high value, our minimum and our maximum. We take our data points, we order them from least to greatest, and we find the median. The median represents the middle value. And that goes right in the center of our box. The median divides my data into two halves, 50% below, 50% above. We find the middle of the lower half, aka the median, and we call that the first quartile. We find the middle of the upper half, aka the median, and we call that the third quartile. That's a review from yesterday. Everybody good with those terms? Then we can find something called the interquartile range, which is the range of those values inside the box. Inside the box represents the middle 50%. So that's kind of like where our averages lie. So to find that interquartile range, we take quartile 3 minus quartile 1. And then this is something that we kind of glossed over a little bit yesterday, is the outliers. We're really going to focus on those outliers a little bit more today. To find an outlier in a graph, we have a little formula. It's where we take 1.5 times the interquartile range. Okay, that's going to give me a number. Let's call that number X. That's going to be like our magic number. Then we need to figure out, hold on, let me do this. From each end of our box, we can either go in any direction, at most, that X amount of spaces, okay? Anything more than that X amount of spaces or anything less than that X amount of spaces away is going to be an outlier in our table. So what we do, I'll write this down for us. We take quartile 1, and we are going to subtract X, and that becomes our lower limit. Or we take quartile 3. Oh, and I'm frozen. Uh-oh. Oh, no. Okay, hold on, pause. When I get a set of data, we're going to now make our own box and whisker plots. The first step, we can see it right here, step number 1. You're going to take these numbers and order them from least to greatest. So right here underneath step 1, take those, I think there's, 10 numbers, reorder them, rewrite them from least to greatest. Go ahead, do it now. All right, so I'm going to write these in order. I like to cross them off. I don't know if you guys tried that strategy at all. I cross them off as I go because it helps me not repeat any and not forget any. Um, 43. Okay. That has to be our step 1 every single time. Then we find the 5 number summary. That's a fancy word for saying these are the 5 points on the box and whisker. I'm going to zoom out one more time back to this. We can see those 5 points very clearly, right? Those 5 points are the 5 things we need to find. Lower extreme, quartile 1, median, quartile 3, higher extreme. So now that my data points are in order, this shouldn't be too difficult. The lowest value here is 33. The highest value is 68. Median means middle. So we're going to find our median first. The way that I'm going to do that is by crossing off one number on each end until I get to the middle. Do we remember what happens if I have 2 numbers in the middle? What's my median if 41 and 43 are both in the middle? 42, exactly in the middle of them. I'm going to split my data here. By splitting it, that means 50% is underneath that median and 50% is over that median. That median is 42. All good there? Okay. First and third quartile. Now that we have it split, we need to find the median of each half. So I'm going to do the same thing. I'm going to cross off one low value and one high value until I get to the middle. For my lower values, my first quartile is 40. Same thing on the upper, one low, one high, until I get to the middle value. That third quartile is 46. Does everybody have their 5-number summary? Okay. Here's our third step. Above the number line, we're going to plot each point from the 5-number summary. So it's nice in this number line, the tick marks are already labeled for us. We're going to have to do that on our own sometimes. But we are just going to go ahead and take our numbers. 33 is our low value. I think these each count by 2, so 33 is over here. 68 is my high value, all the way over there. 42, the median is right in here. First quartile is 40, and third quartile is 46. That's step 3, everybody good? We are going to now draw a box from the lower to the upper quartile. I really hope everybody's using pencil because we're gonna have to change some stuff in a second. But we're going to draw a box. Oh dear. Okay. From the 3 in the middle, from first quartile to third quartile, here's our box. We have to make sure that we draw a line through the box to indicate where the median is. And then we're going to connect the whiskers to that box. That's essentially all we need to do for our box and whisker plot. However, there is one more thing that we need to do to make sure that our box and whisker is as accurate as possible, and that is step 6, where we need to find whether we have outliers or not, because an outlier is going to make our graph look a lot different. Everybody okay with these first steps, though? Okay, so let's go back up here. Remember, to find an outlier, we need the interquartile range. So I'm going to take my third quartile, which is 46, minus my first quartile, which is 40. Those numbers are here and here. So my interquartile range is 6. To find an outlier, I'm going to take that interquartile range and I'm going to multiply it by 1.5. It is always 1.5. That number never changes. 1.5 times 6 is 9. And 9 is going to be like my magic number for finding upper and lower limits. Okay, so I'm going to look at my graph really quickly. I'm going to tell you what this means. That means if I start at the box, start at quartile 1, I can only go 9 in this direction. If I go any further than 9 in that direction, it's an outlier. Same thing this way. I can only go 9 in this direction. If I go any further than 9, it's an outlier. So I need to find a lower limit by taking quartile 1 minus 9, which is 40 minus 9, or 31. And I find an upper limit by taking quartile 3 and adding 9, which is 46 plus 9, to get 55. And that checks out, right? That checks out with the numbers that I have on here. If I literally count 9 spaces from those ends of the boxes, I will end up at 31 over here. And what did I say? 55, which is over here. So then look at my data. If I look at my numbers in order, do I have anything below a 31? No, because my lowest number is 33. Do I have anything greater than a 55? That number 68, that's greater than my limit, so I know that this is an outlier. Oh gosh. Okay, so here's what that means for my graph. 68, we are no longer going to label that as my upper limit. Instead, any outliers get labeled with this star. You can draw it as a star, you can draw it as a little asterisk, but that's no longer my upper limit. I need to go back to my numbers and I figure out what's the next highest number that's not an outlier. And that's 50. So now my upper extreme, my actual upper extreme that's within my data range, is 50. So I'm going to put my new point right over here at 50. And that is the part of my box and whisker plot that I'm actually going to graph. Any questions on that? That's a lot of weird steps for step number 6. Are we okay to move on? If you're good, go ahead and flip it over. We're going to start this problem the same way we start all these problems, by putting these numbers in order from least to greatest. So let's go ahead and do that right now. Okay. I think I got mine in order. I'm going to do a double check really quick to make sure that I didn't miss anything. I think I started with 14 values, so I want to make sure that my new list also has 14 values, which it does, so I didn't miss any. I'm good. Everybody good with that? We're going to identify lower extreme and upper extreme. That one's nice and easy. The lowest value is 16, the highest is 62. My 5-number summary is lower extreme, upper extreme, median, and then first and third quartile. So that's where I'm going to start. To find the median, I need to find the middle. So I'm going to count off 1 low, 1 high, 1 low, 1 high, until I end up right in the middle. I got 2 numbers in the middle, 40 and 42. So what's my median? 41, halfway in between them. I'm going to draw a line right through the middle of my data, because I know that's where the middle is. And then I'm going to find the median of the lower half and the median of the upper half. All right, the median of the lower half is 21, so that's my first quartile. The median of my upper half is 48, so that's my third quartile. Okay, before I start graphing this, because I don't know if I'm going to have an outlier or not, I don't want to mess it up later, I'm going to figure out if I have outliers. So let's go through those steps again. The first thing we're going to find is the interquartile range. What's the interquartile range here? How do I find it? Anybody? We take our third quartile. Oops. We're going to subtract our first quartile. So our interquartile range is 27. I'm going to take that interquartile range And now to determine if I have outliers, what am I going to multiply that interquartile range by? 1.5. Oops. 1.5 times 27 is 40.5. And that's going to be like my magic number here. That means from the ends of the box, from the first quartile and the third quartile, I can't go any further than 40.5 spaces away. So let's start with my first quartile. My lower limit is going to be 21, that's my first quartile, minus 40.5. So that means I cannot go any lower than negative 19.5. Do I have any pieces of data that are lower than negative 19.5? No, I don't have any negatives at all. Then I go to my upper limit. I cannot be more than 40.5 away from my third quartile, which is 48. So I'm going to do 48 plus 40.5, which gets me 88.5. Do I have any values that are greater than 88.5? My largest value was a 62, so no, which means I have no outliers in this problem. Does everybody understand the outliers, what I'm talking about here? Okay. All right, so now that we know we have no outliers, I'm going to graph this like normal, and then I should be able to answer those questions. So let's graph. Oh, so we don't have the tick marks here. You're going to make up your own tick marks. I recommend you try to fill the graph as best you can. You do not have to start at a specific number. Like you don't have to start at 0 or 1. My lowest value here is 16. So I'm going to start at 10. And then I'm going to count by 5s for each tick mark. Or by 10s every 2 tick marks. It's whatever works for you, as long as you know that you're going to see all of the values from your lower extreme, which is 16, to your upper extreme, which is 62. So I'm going to count by 10s here because I know, oh no, sorry, was I counting by 10s? I'm not counting by 20s. I'm counting by 5s. 30, 40, 50, 60. So now my graph has all of the values that I need. All this extra stuff is just kind of extra space. We don't want too much extra space, but if you have a little bit extra at the end, that's okay. Okay, so first point goes at 16, which I'm going to say is about here. My upper extreme goes at about 62, which I'm going to say is about here. The median of my data is 41. Let's say that's there. I have my first and third quartiles at 21 and at 48. Let's say that's here. And now with my 5 numbers plotted, I'm going to draw the box. I'm going to draw a line through the median. And I'm going to draw the whiskers. Any questions on that? Let's answer these questions real fast. What percent? Oh, something else that I like to do sometimes is I like to actually put the numbers on here. I think it's helpful for when we're answering questions like this, so I will label these points. You don't have to do this, but I think it's helpful. So 21, 41, 48, 62. Okay. So then what percent of the data falls between 16 and 21? I can see it's one chunk of my graph, so that's 25%. What percent of the data falls between the first quartile and the third quartile? This is the same for every single box and whisker that we draw. Between the first and third quartile, we should have 2 chunks. That's 50%. What percent of the data falls between 21 and 62? What percent? 75. There's 3 chunks. And then what percent of the data is greater than, or this should say equal to, 41? 41's the median. There's 50%, 2 chunks. Any questions on this? Are we okay if I skip the second one? We're going to go on to the third page. We're going to go to the third page. Everybody follow me to the third page. Oops, did I not erase this? I thought I did. Oh, apparently I didn't erase this. All right. 75 female college students and 24 male college students reported the cost in dollars of his or her most recent haircut. The resulting data is summarized in the following table. So they already have the minimum, the maximum, the first and third quartiles, and the median for us. They already have all 5 of our points. We are going to compare 2 box and whisker plots. One for females and one for males. When we start doing the labels on these tick marks, we have to make sure that they're the same in both graphs, because if they're not the same, I'm not really going to be able to compare them. So I'm going to look for what's the minimum and what's the maximum value that I need, because that's going to tell me how I need to count. So my minimum and maximum, the minimum is 0. The maximum for males or females is 150. So I need to somehow make 150 fit on this graph. I'm going to count by tens. You might do something different than me. I know I need to start at 0, 0, 10, 20, 40, 60. So each one of my tick marks is 10. And I'm going to do the same for females and for males. Okay. Now, like I said, in this table, they've already given us our 5-number summaries. So I want you to go ahead and plot for females and for males. Plot their 5-number summaries on here. Make your box and whisker plots. Okay, here's my box and whisker plot for females. Hopefully yours looks something like this. I'm also going to put labels on these points because I find it helpful. So this is 20, 31, 75, 150. And I'm going to do the same thing for my data about the males. I don't know what they're doing in there. Seven. All right. Here's my box and whisker plot for the males. I'm going to go ahead and label those as well. 9.25, 17, 20, 35. All right. Everybody got these too? Hopefully graphing it shouldn't be the difficult part. The difficult part is kind of answering these follow-up questions. So, letter B. How would you describe the difference in haircut costs? So, each one of these data points is the cost of somebody's haircut. What do you think? Make some observations based on what you know about female and male haircuts. Why do you think it looks like this? There's not really a wrong or right answer. Just tell me, why do you think it looks like this? What observations can you make about the shapes of these graphs? Anybody? What does this mean? Nobody's ever gotten a haircut before? You don't know what a haircut is like? Okay, why is the female one so far spread out? Why do you think? It goes from 0 all the way to 150. Why do we think that is? Cost of a haircut for a girl. What could they be doing differently? Oh my gosh. This is the quietest you guys have ever been. What could they be doing? They could be getting different types of haircuts. Maybe the girl went in there, they got a perm. Maybe the girl went in there and they got like highlights done to their hair, okay? That costs a lot of money. So that's why the female haircut might cost that much more. Let's write that down. All right. Why is the mean greater than the median for both males and for females? So they gave us that data here. Let me look at my table. What would cause the means, remember mean means average, to be greater than the median, which is the middle? What would cause that in a set of data? Not even specifically this set of data, any set of data. Why would the average be way higher than the middle number? What would we have in there that would make our average go way up? James? Probably an outlier. I'm going to go out on a limb here and say that this person who spent $150 is probably an outlier in her haircut. So the mean being greater than the median usually means the data is what we call skewed by an outlier. All right, so then with that in mind, which do we think is the most accurate measure of the center of this set of data? Do we think the center is most accurately represented by the median or by the mean? When we have an outlier that's making our data so skewed, do we think that that mean is still accurate? Probably not. I would say if your numbers are this far off, 31 to 52, that's probably a sign that your mean is not super accurate. So we're going to go with the medians here. Okay. Any questions?